Okay, and then, so these functions are x to the 1/3 and negative x to the 1/3. Okay. All right, so we want to find the hydrostatic force on that plate. Yes?
Uh-huh.
Okay, good. Now we're talking. This video is going to need some editing. Okay, so I need to know what this value is right here. Do you guys agree? Okay, now how can I find, so this is the x value when y is equal to 2, which would be, so when y is equal to 2, x would have to equal to 2 cubed, which is 8, right? And negative 8. Okay, so everything else is the same though. So I need to find the area of a slice. Interesting. Area of a slice, so let's grab a slice here. Not a good choice. Alright, so I have this slice, thickness delta y. And then I need the length, right? At that point, what is it equal to? The length. At any arbitrary slice, the length would equal to
2.
Well, if you take away half the function, it's about 2, yeah.
It's changing, right? So you go up and down, right? So
2 minus y.
So it's changing as you go here, right? As this slice moves up and down.
Triangle again, just do half of it.
No, it's a lot easier than you guys are thinking.
Is it just the function?
No, it's not. Well, it's related to the function, right? But what aspect of the
Is
function?
it the inverse? Like the
The y slice there, the slice in the x direction is going to be equal to 8 minus whatever the y value, or
It's
times the function.
so right here. All you're doing is you're looking at the distance from here to here, right?
Uh-huh.
The distance from here to here,
So f of y.
which is simply the x value, right?
Yeah.
Okay, but everything has to be in terms of
Y.
y.
So then x is equal to y cubed.
Exactly. So you have to solve for x here, right? Because everything has to be in terms of y because your slice is moving up and down the y-axis, right?
Yes.
So the length is equal to x, which is equal to y cubed, right? Does that make sense? But it's not 1x or 1y cubed, but it's 2 twice, right? Because you're going all the way over here. So the length of the slice is 2y cubed. Okay, so then what would the area of the slice be?
Multiply that by some delta y.
2y cubed delta y. Let's say this is in feet, right? So square feet. So then the force on that slice would equal to what? Omega times?
Depth.
Let's put the 2 right here. 2 omega y cubed delta y. So that's the area, right?
Uh-huh.
So the pressure times the area times the depth. What's the depth? Let's write this down.
2 minus
Hello. Duh. Okay.
2 minus y.
The depth. So remember that it's relative to the point where you're at. So if this right here is, that's the y value, right?
Uh-huh.
That's the y value where the slice is located at. So you want to give the depth. So given y, you want to be able to say what the depth is at that y value.
2 minus y sub I.
2 minus y sub I, right? Because the depth is the distance. Notice the depth is the distance from the top to the slice, right? And that is 2 minus the y value. Does that make sense? How you get it? So the depth is 2 minus y sub I. Okay. And then the force written as a sum is equal to sum from 1 to infinity, right?
Mm-hmm.
Because I said equals to.
Yeah.
2 omega y cubed, 2 minus y sub I, delta y. So here I have pressure, area, and then the depth. Okay, and then written as an integral, this is equal to the integral.
Omega outside.
Yeah, you can put it outside. Or just leave it inside. Oh, I forgot the I there. Okay, and then what's my integral? What am I going from and to?
Oh.
0 to 2, right? 0 to 2. And that's it.